addition reactions for alkene. Okay, so for alkene, difference between alkene and alkane is that alkane you will only have one substitution reaction, which is with the halogens. But for alkene, in total, you have 6 different addition reactions. Okay, and the first thing that you need to know is that all reactions will happen at the double bond. Okay, so if they give you alkene structural formula and you want to know where does the reaction happen, you find where is the double bond first. Okay, so remember all reactions will happen at the double bond. So addition reaction is a reaction in which atoms are added. That's why it's called addition, meaning you just add in the atoms. Okay, so where do you add in? You add in at the double bond. Okay, to form single covalent bond, meaning what? Okay, the reason why we call this or we call alkene as unsaturated is because if you look at the double bond here, what we can do is we can break the double bonds. Alright, so when you break the double bonds, I am going to produce something like this. Meaning after you break the double bond, you can produce 2 more spots here. 2 more additional places for the other atoms. Alright, so the other atoms will be added into these 2 places. Okay, that is why all the reaction will happen at the double bond. So basically what is happening is that we break open the double bond, you open up, okay, you form 2 more new bonds. Okay, so these are the single bonds. That is why for alkene, right, all addition reaction, you are basically changing from an unsaturated to saturated. Saturated meaning that these bonds can no longer be cut or be broken to separate anymore, cannot. Okay, you can only separate the double bond here, break to form 2 single bonds. Alright, so once you do that, it's already saturated, meaning no more reactions can happen. Okay, so technically whatever that is added will be added to the position of the carbon double bond. So in this topic, there's a lot here, alright. You're going to learn 6 different addition reactions. Okay, first thing you need to know is the names. Alright, if you add hydrogens in, we call it hydrogenation. If you add halogens in, meaning you add group 17 elements, chlorine, bromine, or iodine, we call it halogenation. Alright, if you add hydrogen halide, meaning HCl, HBr, HI, so all these are hydrogen halides. Okay, this one no name lah. If you add with water, hydration. Okay, so you need to know the names of the addition reaction. So in other words, if we say an alkene undergoes hydrogenation, meaning you immediately you understand is this one we are adding hydrogens to the carbon double bond. If we say hydration, meaning that we are adding water into the carbon double bond, because hydration, hydrate meaning water. Okay, all right, and then you have addition of potassium permanganate. So this one later I will show you what does this mean. Okay, technically you're adding the oxygen in, right, because this one is an oxidizing agent. So addition of acidified, right, you are basically adding adding oxygen. All right, adding oxygen. Okay, and then polymerization, this one you learned before last year during the chapter 9. Okay, so we are just going to go through very fast through polymerization. Okay, so I'm going to focus a lot more on the first 5 reactions: hydrogenation, halogenation, hydrogen halide, and also hydration and acidified potassium manganate. Okay, so let's look at the first one, hydrogenation. Alright, so hydrogenation meaning you are going to add hydrogen. Okay, and then you need to know the conditions, meaning what is the temperature and what are the catalysts. Okay, so technically your nickel and platinum will act as a catalyst. So for an alkene, if you look at the structural formula here, if after I add in the hydrogen, you will notice that I'm changing it into an alkene, right? So technically an alkene can be converted into alkene through hydrogenation. Now it's very important that you write the conditions here. Okay, when they ask you to write the balanced chemical equation or the structural chemical formula to show the reaction of hydrogenation, please include the conditions here. What catalyst at what temperature. Okay, alright. So hydrogenation. Now, one classic example of hydrogenation is the manufacturing of margarine. Right? Technically, you can convert a margarine and butter by using hydrogenation. Okay, but that one later on we will focus more when you go into the application. Right? So hydrogenation is used to prepare an, okay, remember it's saturated, meaning it's alkene. Okay, from unsaturated alkene. Okay, so this is the example. So in the exam, two ways of writing your chemical equation. So one, they will ask you to draw the structural formula, meaning you need to draw out like this. Okay, or you can write it in your chemical formula, meaning like this. Right? It doesn't matter how you write it. Okay, just make sure that you always calculate. I think there's a mistake here. This one is wrong. Okay, this one should be C2H4. Right, it's not CH4. Remember, alkene, you start with two carbons, not one carbon. So this one is wrong. Okay, so this is the hydrogenation reaction. So what happens is that the hydrogens, okay, they will go, oops, right, the hydrogens will come and attack the double bond. Alright, so when they attack the double bonds will break up. Okay, oh man, alright, okay, double bonds, they are going to break up. So break up, okay, and then the hydrogens will fill in the double bonds here. So that's why you see two hydrogens go in straight away. Okay, so it's actually very simple. You just add the two hydrogens to the double bond there. Alright, meaning take these two masuk sini, then that's it. Okay, so for example here, propene. Alright, since I know if hydrogenation, I'm converting from a propene to propane. Okay, what is the general formula for alkene? Remember, general formula is C2, right, oh, just remove this, okay, CnH2n plus 2. Okay, you add two hydrogens in, so this one, your molecular formula will be, okay, C3, H here initially is 6, add 2 in will become 8. Okay, so you just check with your general formula whether it's correct. So 3 multiplied 2 is 6 plus 2 is 8, so this one is correct. Alright, so for butane, C4H10, because you put in another 2 hydrogen in. Alright, so remember, to change an alkene to alkane is through hydrogenation, add 2 hydrogens. Right, so that is the first thing about hydrogenation. Okay, so hydrogenation of an alkene, this one is the conclusion, with the presence of nickel as a catalyst, will produce alkenes. Okay, so first reaction, that hydrogenation. Alright, so let's look at the second addition reaction, which is the addition of halogens. Okay, chlorine, bromine, and iodine. Alright, so this one is different compared to substitution. If substitution, we need UV light, but in this case, we don't need the UV light. Alright, so here you don't put UV. Okay, UV is only written when you are doing for alkene substitution reaction. Okay, so same thing, bromine will go in. Alright, bromine will go and attack the double bond. Okay, so this one will break open. Alright, therefore the two bromines will be added in. Okay, so this one, another difference between substitution of halogen and addition of halogen is that for substitution, you can only substitute one halogen at a time. But for addition, immediately these two bromine go in straight away. Okay, So this one, after the 2-bromine goes in, right, you will see that the name will be different lah. Okay, so I'm going to introduce a little bit of the naming concept here. Okay, 1, 2, the number here is referring to the number of the carbon atoms, the position of the carbon atoms that the bromines are added in. Okay, now for ethene, right, since this you only have 2 carbons, meaning that this one I can put it as carbon 1, this one I can put it as carbon 2. I can also put it the other way around, meaning this one is carbon 1, this one is carbon 2, also can, because this one is 2 carbons only, symmetrical. Alright, so it doesn't matter which one is 1, which one is 2, it will be the same. Okay, so technically, alright, the number here refers to the position of the carbon atoms that the bromines are added in. Okay, so the bromines here, alright, so because they are attached to the first carbon and the second carbon, that's why it's called 1, 2. Okay, since it's 2 bromine, we call it di. Okay, dibromoethane. This one is very important. Okay, remember, initially it's an unsaturated. After addition reaction, it becomes saturated. Alright, meaning that you need to change the name. This one is already becoming an alkane parent group. Okay, so that is why the name you are changing from ethene to ethane. Okay, so that is the naming of the compound here. 1, 2, dibromoethane. Alright, so this one is the molecular formula. Okay, there's an important reaction here is the observation. Alright, so when ethene gas is passed through bromine water, okay, bromine water, the color is brown. Okay, now since you will have a reaction with the bromine water, right, meaning the brown color will disappear, meaning that the bromine water is the colorized, meaning the color will change from brown to colorless. Alright, so this particular reaction can also be used to differentiate, okay, an alkene and alkane. Alright, because bromine water can only react with alkene. So if I have 2 test tubes, alright, so you can imagine if I have 2 test tubes, one test tube is added with alkane, another test tube is added with alkene. The test tube that contains the alkene, the bromine water will change from brown to colorless, whereas for alkene, the bromine water will remain as the same color, which is brown. Okay, so this one, halogen reaction or halogenation, can be used to differentiate between alkene and alkane. Right? Okay, so let's move on to the next addition reaction, is the addition with hydrogen halide. So you will have HCl, HBrHI. Okay, so same thing that will happen here is that your hydrogen or hydrogen chloride. Okay, so what will happen here is that, remember, it will be added to the double bond, right? So here you will open up. Okay, and then the hydrogens will move to here or here, doesn't matter where, whereas the chlorine will go to the other carbon. Okay, so when you draw the structural formula, draw the carbon first, and then you can draw in the HCl first. Hydrogen goes here, Cl goes here. Okay, and then you fill up the hydrogen. Okay, remember, you must always complete your structural formula, cannot leave empty the other hydrogens. Alright, so this is the structural formula for chloroethane. Okay, don't worry about the naming. The naming I will teach you in the next part after I finish with all the addition reaction. Alright, now since I only have one chloro or one chlorine, that's why we only have chloro. If I have 2 chlorines, this one will become dichloro. Okay, and then remember, once again, I'm repeating this, you are changing from an unsaturated to saturated. That is why the name is ethane and not ethene anymore. Okay, so make sure you remember this. Alright, so that is the reaction, the addition reaction of hydrogen halide. Okay, it doesn't matter the position of the hydrogen and chlorine, it does not matter as long as you fill it at the correct position, then correct. Meaning, in other words, I can also put it at the hydrogen at here, chlorine at here also can, doesn't matter. Okay, it will be the same. Alright, okay, next is addition of oxygen or the hydroxyl group. Alright, so technically, right, this one is to provide oxygen. Okay, now with the addition of potassium manganate, right, you are going to add in two hydroxyl groups. Okay, you are going to add in two hydroxyl groups in the double bond. Alright, so an alkene, this one is the observation. You need to know all the observations for the bromine and also the potassium permanganate. This one is purple color. Potassium permanganate KMnO4 is purple color. Alright, so this reaction can also be used to differentiate a saturated hydrocarbon and unsaturated hydrocarbon, meaning alkene and alkane. Alright, so technically to differentiate between alkene and alkene, you can have three reactions. First is combustion. Second is what you call addition of or halogenation. Third is addition of potassium manganate solution, acidified potassium manganate solution. So these three reactions can help you to differentiate between alkene and alkane. Okay, so in this case, as I said earlier on, that the purpose of the potassium permanganate here is only to supply the oxygen. Alright, therefore if you look at the equation here, right, we don't write the Kmn because it does not play a part in your reaction. Okay, so what is going to happen here is that you are going to add in two hydroxyl group, two OH group comes from here. Alright, so again, break up the bonds. Okay, so C, C, and then you are going to add in two OH group, meaning one goes here, the other one goes here. Alright, so two hydroxyl groups. Okay, so this one is the addition reaction of potassium manganate solution. Alright, so this one, the name is, again, this one can be labeled as what we call carbon 1, this one is carbon 2. Sorry, carbon 2. Okay, so that is why if you look at the name, ethane 1,2-diol. Alright, so in other words, remember number here refers to the position of the carbon atoms that the groups are attached to. Alright, so since I'm attaching the hydroxyl group to first carbon and also to the second carbon, that's why we put the number here 1, 2. If I only attach one hydroxyl group here, meaning I put one only. Okay, meaning one ethanol, for example. Right, so diol is because we have two hydroxyl group. Okay, so technically when you do this reaction, right, you are actually changing from an alkene. Okay, this is alkene, and then this one is actually an alcohol. Alright, so when we say alcohol, meaning you have OH group in the structure. Okay, just that in this case, since I have two OH, that's why it's called diol. If I only have one OH, right, this one will be called ethanol. Okay, so you need to understand, from now on, you need to understand if you see OH group in the structural formula, that is actually an alcohol. Right, so C2H4 plus water and oxygen, alright, meaning is this one, acidified potassium manganate solution. Okay, so our molecular formula, we can write it as like this. Okay, C2H4, and since I have two OH, right, I can put it like this, OH and then bracket 2. right? This is one way of writing the molecular formula. So normally when we write the molecular formula for alcohol, right, we always put the OH at the back. Okay, so it's easier for us to identify. All right. Okay, so in this case, for example, propene. This is propene. Addition of potassium manganate solution. What you're going to get is, so I'm going to draw out for you so that you can see. Right. So propene, 3 carbons. Okay, so I put it here. Okay, I draw out H, H, H. Okay, and then plus this one, H2O plus oxygen. So what I'm going to get is, remember, break the double bond. Okay, actually you don't need to show this in your exam. I'm just showing you. Alright, so break it up, becomes saturated. Okay, and then here. Alright, since the double bond was here, right? So meaning the 2 OH is added here, here and here. Okay, and then I fill up the rest. Okay, H, a lot of H. Alright, now how do we put the numbers? Alright, which one is carbon 1, which one is carbon 2 and 3? Normally we refer to the double bond. Okay, so this one, since the double bond is here, right? So this one is carbon 1, carbon 2, and then this one is carbon 3. Okay, alright, so since this one is first carbon, second carbon, right? So meaning when I put the name, this one will be propane. Just close this first. Okay, propane dash. Okay, first carbon, second carbon. So 1, 2, sorry, no, 2 dash diol. Alright, so there's a certain format of writing the chemical name for organic compounds. So how do I know when to put the hyphen? How do I know when to put the dot? Right, this one later on when I teach the naming, I will show you in detail. When do we put the hyphen? When do we put the dot? Okay, so this one is just like a prelude, right? An intro on the naming of organic compounds. Okay, but first you need to know the reaction. So that is the reaction of alkene with acidified potassium manganate solution. Okay, next will be addition of water, hydration, meaning you add water in. So when you add water in, you are actually reacting with steam. Okay, we are not dissolving it in water, meaning you put it in hot steam, okay, high temperature. Alright, and then you have phosphoric acid as your catalyst. Okay, so you need to know the temperature and the pressure here. So when you write the equation, you must always include this in your equation. Okay, so for your water, okay, normally the water is like this, HOH. Okay, alright, so one H will go to the carbon, the OH will go to the another carbon. Okay, so break. Alright, so what you will get is C, and then one H will go here, the other one, the OH will go to the other side. Okay, so hydrogens, hydrogens, hydrogens. Okay, so remember just now I mentioned, right, if you see OH in the group and only OH, meaning others all are hydrogens and you only see OH there, then this is an alcohol. Okay, alcohol, the one that you always drink at home, alcohol is slightly different, that one is processed. Alright, so ethanol here. Okay, so this is the one that we are using now to kill the COVID-19. Your sanitizer all contains ethanol. This one, this is the chemical structure. Alright. Okay, so remember, to change an alkene to alcohol, the reaction that you need to use is hydration reaction. Okay, so this one is the molecular formula. So as you can see, we always write the OH at the back. Okay, meaning we don't put the H in and then we don't write it as C2H6. In other words, if I show you another way of writing, right, we can also write it as like this, C2H6O. Okay, but normally for alcohol, we write it in this way. Okay, the reason being is because when I see the OH, immediately I know that this compound is an alcohol. Alright, so that's why we normally write it in this format. Okay, so other examples, alright, complete the following. So propene. Okay, so again, the same thing, you just look where is your double bond. Since my double bond is here, so I just break open. Alright, and then, this is where it becomes tricky. The OH can go to the first carbon, or it can also go to the second carbon, right? So for this particular reaction, you will get two products. Okay, this one you must remember, for propene onwards, normally you will get two different alcohols. All right. Okay, so here, break. So the first one is here. Let's say if I put it at the first carbon. Okay, first carbon meaning here, OH. Okay, this one is, oops, sorry, I forgot one more carbon here. H. Always must fill in. Okay, this is when the OH is at the first carbon. Okay, remember, since this one the carbon double bond is here, meaning this is first carbon, it's the second carbon. Alright, now the second is when the OH is added into the second carbon. Okay, so 1, 2, 3, and then the OH is here. So there are two ways where the OH can be added into a propene. Okay, it can go either into the first carbon or the second carbon. Now, technically, the what they call the molecular formula is still the same. All right, you are still getting C3, okay, H6OH. Still this chemical formula, just the position of the hydroxyl group is different. Okay, so that's why this one is called propan 1-ol, or normally this one we will write it as 1-propanol. Okay, and then this one we will write it as 2-propanol. Okay, so two ways of writing. You can write as propan 2-ol or 2-propanol also can, but normally write it this way lah, easier to write. Okay, so technically for propene onwards, normally you will get two products lah. Okay, so C3H6, this one we only write the molecular formula, right? So C3H6OH. Okay, so this one C4H8, addition of water. So what happens is that, let me check, 1, 2, 3, 4, 5, 6, 7. Oh, sorry, this one is 7. Okay, this one is 7, not 6. Okay, C3H7, OH. C3H7 OH, this one is butene. Okay, so C4H9 OH. Okay, so technically this is the reaction that you must remember. Alright, if I want to change an alkene to alcohol, it is hydration reaction. Okay, you must know what is the catalyst, what is the temperature. Okay, so this one is the general formula for alcohol, CnH2n plus 1 OH. Okay, alcohol will land in the next part, the non-hydrocarbon part. Alright, so that is the addition reaction of water. Okay, finally, alright, polymerization. So remember that polymer is a very big molecule, alright, and then you are joined together using monomers. Okay, so remember, small alkene molecules undergo addition reaction at high temperature. Okay, thousands of alkene molecules join together to form a long chain giant molecules called polymer. Okay, so remember the analogy that I have given previously. Alright, so if I have a necklace, okay, so each of this necklace, so each of this one is a monomer. Okay, monomer. One is monomer. This whole thing is called polymer. Okay, so the small repeating units, meaning the small circle here, the each blue circle here, are called monomers. Okay, now for polymerization of alkenes, this one we have learned previously during Form 4. So remember, you always shift the what they call the bonds of the other atoms top bottom, so that left and right are empty. And then when you break the double bond, it's going to go to left and right. So you open up, it becomes like this. Okay, and then the N here refers to how many monomers do you have. So this is one monomer. Okay, so remember that. So remember, for monomer, meaning for each blue dot here, the blue circle here. Okay, this one is referring to one monomer here. Right. So if here I have 8, meaning I have 8 of this thing repeating again and again. Right. Sometimes the question they will ask you to write 5 repeating units, so you need to draw this 5 times. Okay, you just continue lah. Okay, so this is for ethene. All right, and then when I change it into a polymer, we call it as polyethene or polyethene. So can. Okay, so propene. Now for propene, right? Since I have 3 carbons, correct? So initially it's like this: 1, 2, 3. And then I put the H here, H here. Okay, let me just draw this out first. Right. So as you can see here, right, how they arrange is that I arrange so that my left and right must be empty, right? Remember, double bond is here, meaning that this side and this side, left and right must be empty. So what I do is I'm going to take this one, I'm going to shift it downwards, meaning I rotate it downwards, and then this group, I'm going to rotate it downwards also, so that it becomes like this. C double bond C, H, H, and then this one is the one that I bring down. So this one I can simplify and write it as CH3. Okay, we can write it like this. Okay, so that you can see now my left and right empty. So once my left and right empty, I can break my double bonds, so that one will go to the left and then another one will go to the right. So this one is the same as this one. Okay, just that my CH3 is at the bottom here, while the CH3 is at the top part here, but it's the same thing. Okay, so remember we're going to break left and right. So polypropene, so C, C, H, CH3, H, and H. So since I break left and right, then I'm going to draw the bracket here, and then N. Okay, so this is polypropene. Alright, so that's it for the polymerization reaction, and that concludes the addition reaction of alkene. Alright, so there's a lot here. Okay, you really need to make sure that you know how to convert an alkene to other things. So basically this is like a summary for the reaction of alkene, addition reaction. Okay, so if I want to change to alkane, meaning it's hydrogenation, which is this one. Alright, and then if I want to change it into an alcohol, I can either use with steam or acidified potassium manganate. The only difference between these two things is that this one, I'm only putting in one hydroxyl group. This one, I'm putting in 2 hydroxyl group. Alright, and then if I want to change it into an haloalkane, haloalkane meaning you will see that there's a halogen in the alkene parent chain. So it's either you do it with the hydrogen halide or with the halogen. So these two reactions. Okay, these two reactions will change in from an alkene to an haloalkane. And then finally is the polymerization reaction. Alright. So that concludes the addition reactions of alkene. Okay. So that's it for today. So if you have any questions, remember to message me anytime. Alright. Okay, I will give you some exercise later on. Okay. Alright. Bye.